In general chemistry, we learned the atomic structure of an atom is composed of a nucleus that has protons and neutrons, and it's surrounded by an electron cloud. Now, this electron cloud is, of course, electrons, right? So, in a typical atom, well, we usually see the tiers of electron shells that surrounds the nucleus. Lithium, for example, has an atomic number of 3 and one electron in the outer shell. Now, that outer shell is also called the valence electron, right? So let me write this down. Outer shell, or valence, I should say electron shell, outer shell, right? So let me erase this right here. So lithium, we're seeing how it's really giving away its electron, in this case, to fluorine. Now, the reason it's doing this is a concept that we will learn in this video. It's called electronegativity, right? Lithium has one electron in its outer shell, right? And it would rather give away its electron to become lithium plus, and that's really the stable form of lithium, so that fluorine can get what it wants. Fluorine is so close to having its octet full. It's filled octet, right? Right now it has 1, 2, 3, 4, 5, 6, 7 electrons in this outer shell, right? It needs 8, so it's this close. So it would want to take away the electron that's on the outer shell of lithium so that it can meet its goal, right, of having a full octet. Lithium is so really far away from having 8, would rather give away its electron on the outer shell for it to be stable. So we're forming lithium plus and fluorine minus, right? This right here is actually a salt, right? A salt, what a salt is when you have a metal and non-metal okay, actually let me rewrite that, because for some reason my metal and a non-metal, right, coming together, right? So we having lithium fluoride. I mean, you also see this too in NaCl. We see this in potassium chloride. We see this a lot in chemistry. So now that outer shell, the valence electron, typically gets involved in bonding because it's usually reactive. It's of its reactive nature. The valence electrons get involved in bonding, right? This one that we just did was called an ionic bond. Now, an ionic bond is where you have, or when you have bond, is when you have an atom that gives away its electron, right? The reason I mentioned this is because we learned something else, another bond in this video, and it's called covalent bond. Now, covalent bond we learn in chemistry is when we have two atoms that are sharing electrons, right? So the classic example of this is actually H2, which we will get into. But let me write down the covalent bond is the sharing of electrons, right, by two atoms, right, or even more. But so atoms are constantly trying to have their outer shell filled, right? They're trying to have a closed shell or a filled shell, and one way we can achieve this is by giving away an electron, like an ionic bond, right? An ionic bond, or we can share, right, electrons to meet that 8 electron outer shell rule, right? So, and this is in covalent bond, right? So another thing that we have to keep in mind is when we have something like fluorine, right? When there's it has 7 in its outer shell, it is so strong, right? And that's when we're getting into the concept of electronegativity. Now, there is a trend for electronegativity. So as we're moving from left to right, the electronegativity is increasing. So really, the most electric negativity atom in the periodic table is fluoride, right? We don't really mention or talk about noble gases, right? When we're talking about electronegativity, because they have a full octet, right? Right. So fluorine being a halogen is the strongest or the most electronegative atom, right? So that's why lithium was so willing to give away its electron, because fluorine it's so eager to take one away to have its octet filled. Now, so basically electronegativity, I will write down, is how bad, right? True. Negativity. How bad an atom wants to gain an electron, right? And we discussed before where it increases from left to right. Now, there's another bonding that we can talk about, and that's covalent bonding. Covalent bonding. Now, this is where two electrons are shared, and unlike ionic bonding, they don't completely take it away. Now, I did talk about H2, right? Now, usually, H has hydrogen has one electron, right? Right. This is really unstable. When it meets its twin, it has another H, right? They usually come together to form that diatomic molecule, right? To form H2, right? And this dash is representing the two electrons coming together, right? So you can also see this too, and N2, F2, chloride 2, right? So all of those are diatomic molecules, right? So 2, N2, H2. You see, these are all diatomic molecules, right? So H has one electron, and it's really unstable. Therefore, with the help of another hydrogen, it meets together so that it can have that stability, right? So we can actually see this. Let me actually draw out Cl2. Right? This is really how it looks. Now, a lot of the times in orgo, which I will talk about towards the end of this video, sometimes they don't really draw out the non-bonding electrons. So it's usually up to you to infer or just know that there's electrons that are there. So really, we know that it looks like this, right? This was formed by two chlorine coming together. Actually, let me draw this out in another color, actually, so I can show you. Right? What I'm about to do is really how it comes together, just one head or one side arrow, single arrow, coming together, and then they're forming this, right? 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 So, and then this looks like this, right? We can also see this too in methane, right? When we have carbon, right? We know that carbon has 4 valence electrons, right? And we know this by looking at the periodic table, by the way. Let me go all the way back up to the periodic table to show you a little something. So we tell the number of valence electrons by the group number that the atom is in, right? So we have hydrogen right here. This is group 1. This is 2. This is 3, boron. Carbon's in group 4. Nitrogen's in group 5. Oxygen is 6. 7 is fluorine right here, right? So this whole group, right? This whole group right here has 3, and this whole group right here has 4. This one has 5. So we know that carbon is in group 4, right? So it has 4 valence electrons, right? let me go back to where I was getting to. So for hydrogens, right? Right. We know that this is really what it looks like. Right. We have this hydrogen right here. It's gonna come, right, make that bond here. Make that bond here. I'm actually gonna draw the hydrogen in different colors just so you can see it, how it's coming together. Right? And then we have make that bond here, and then make that bond here, which is forming this methane. Right? The carbon we learned in a different video is neutral, right? It's neutral, right? So we are able to see this coming together, and that's really how it looks when it's sharing, right? In electrons, right? So another thing that we can see is that we can have multiple bonding, right? For what I mean by this is, let's say I actually draw out N2, right? So, you have to keep in mind that you have to have the outer or the octet rule in mind when you're drawing this thing out, because you can't draw out this right here if I were to ask you, right? Because you would know that, because if we do this right here, right? Yes, we do know that this is 2, 3, 4, 5, 6, 7, 8, 9, 10. And yes, it has they come together and they form 10, right? 10 electrons. So yeah, this is 10 electrons. But there's one thing that we disregarded. The nitrogens, they're not connected, or their outer shell doesn't have 8. We need to meet that rule, right? So right here we only have 5, right? So the only way we would be able to achieve nitrogen having 8 valence electrons, and also keeping in mind we have to keep this 10 number the same, right, is by having multiple bonds. Right? So really, N2 should look like this. Now, a way to better see this is this right here, right? Where we see that this nitrogen here nitrogen 1 has access to 8 valence electrons, and also nitrogen 2 has access to 8 valence electrons, right? So that's 3 bonds and 2 non-bonding electrons, 8, right? That is the only way we would be able to keep the 10, right? And also having 8 electrons in the outer shell. A lot of people are probably asking, where are you getting that 10? Well, we know that when we're forming, when 2 atoms are coming together, the number of valence electrons on each atom comes together, we add them together, and it needs to be the same number in that dash formula. So basically, if I were to do chloride 2, we know that chloride is in group 7, so it has 7 valence electrons. So 7 times 2, that's 14. So in that dash formula, right, we need to keep in mind that we have to keep 14, right? So it is 2, 4, 6, 8, 10, 12, 14. And also, this chloride has access to 8, right, electrons, and this chloride has access to 8 electrons. So we're valence electrons. So we're keeping both rules in check with having this multiple bonding one. So we will talk about this more in another video, but this was just really more of an introduction to it. And I can actually ask you, hey, draw out ethene for me, or ethene. See 2H4 for me, right? So if I were to ask you to do this one for me, C2H4, right? We know that it would be drawn out like this, right? Right? Right. And then that's really because of we have the octet rule in place, right? And we know that this needs to have a total of, this right here is 4 times 2. This is 8 plus 4 times 1 is 4. So 12. So it needs to have 12 total electrons. So this is 2, 4, 6, 8, 10, 12, right? And the carbon has 4 bonds, and it has access to 8 electrons, right? So this is an example of covalent bonding, right? We're able to see this one, ammonium, right? And it's close to methane, but it's a little different. We're seeing how N right here, this nitrogen, has a charge on it. We don't usually see this a lot, or in the beginning. This is a concept called formal charges, and this will be discussed in the next video. Before I actually move on, there's actually a couple things I actually want to talk about, and that's really the foundation of oral. Now, you would be expected to know that in a structure like this, you don't always see the bonding of everything. So, for example, this oxygen right here, we know that it has a bond to H, really like this, but instead, chemists, or whoever write these are really lazy. They just don't show this, this bond right here. So it's not here, but we have to know that it's there, right? When it's drawn for just to make things simple, they disregard that bond. And also too, I wanted to talk about the unseen non-bonding electrons, because we know that in this oxygen that there's 2 sets of or 4 total non-bonding electrons, but it's not usually drawn, right? When we have a structure like this, like in vitamin C, right? And then we know as well there's this right here, right? And the reason we know is because it's there's 2 of them, or 2 sets, is because this is 2, 4, 6, 8. It's forming it's meeting its octet rule, right? And right here, this one too, it already has 2 bonds, so that's 4, right? So 2, 4, and then this 6, 8, right? So these are the 2 things that you have to look for. Not every time that you will see the bondings, and also too, you wouldn't see the non-bonding electrons. I mean, you can see this in CH or THC chemical formula, and I wanted to actually zoom in this one where this CH3 on the end. Most of the times, you would actually just see it just regular like this, right? They wouldn't waste your time drawing CH3 on the end. I wish they would, but you just have to get used to it. And so you know that every end, right? There's a carbon that's connected to 3 hydrogens, right? And that's every end. And every kink or corner, right? They also call it kink, has a CH2, right? And the 3D or the 3-dimensionality of this would actually be something like this, which we will talk about in another video. That's how it would look. Right? This N right here, right? So just keep those in mind, and the next video will discuss formal charges.